So in this lesson, we're going to talk mostly about how to graph a function now, given the rule. So what you should have with you right now is the worksheet that was supposed to be given to you. This is the first question from that worksheet that deals with graphing. You should also have with you a very handy calculator, as well as a ruler, because now that we're talking about graphing linear functions, it's a line. And you need to know how to draw a straight line, and the only way for you to do that, I don't care what you say, is by using a ruler. Neatness will count in this case. So what are you given right now? What is in front of you right now in this question? Well, the first thing that you should see up top here is I give you the rule. The rule is y equals 2x plus 1, and now this is what you need to put onto this beautiful Cartesian plane that I've given you. But I've also given you this table of values. Now, in the past, a few lessons ago, we briefly went over this, where you were given a table of values, or you had a table of values, and then with it, you had to put something on a Cartesian plane, and you had to make your own increments depending on the numbers that you were given. It was part of the Everest project. But now, in this case, you have an empty table of values, and you have no idea what points you need to put on this Cartesian plane. So very simply, the first step that you should do with these questions is complete a table. That's the first thing that you should do. Okay, step 1, complete the table. Now, how do you do that? You've done this before, but you may not have actually realized that you've done this. So in this case, you have this x here is -3. But what you're looking for here is, what is this y? What is the y when x is -3? So what we're going to do is we're going to take the rule that you're given, so y is equal to 2x plus 1, and you're going to say, okay, well, what if I replace this x with what is given to me in here, right? So I would get y is equal to 2, and then x is -3, so let me just replace it, plus 1. Now you can use your calculator, you can do it in your head, but 2 times -3 is -6, and if you add 1 to that, you get that y is equal to -5. So we've just determined that when x is -3, y is -5. And we're going to do that with the other points that I've given you. So again, start with your rule. You have y is equal to 2x plus 1. In the second one here, you have that x is -2. What's y? So in your rule, you're going to replace this x with the -2 to figure out what is y when x is -2. You can do it on your calculator, you can do it on your head, but 2 times -2 is -4, plus 1 is -3. So when x is -2, y is -3. And we're going to just fit that into our nice little table here. Next up, we have 0. So y is equal to 2x plus 1. Replace my x with 0. Y is equal to 3. No, that's wrong. Y is equal to 1. 2 times 0 is 0, plus 1 is 1. Even I make mistakes, as you can see. 1. Over here, y is equal to 2x plus 1. The next one is y is equal to 2 times 1 plus 1. Y is equal to 3. Let me just double check here to see if that's true, because I am doubting myself. Yes, it is. I'm going to do the last one, but I already know. I'm already anticipating this question. Do we have to do this for every single one? When you're starting out, considering this is the first time you're doing this, my answer is going to be yes. But as you continue going on, you don't need to do all this work. You can just fill in the table however you want, as long as you have the right answers, of course. But I'm going to do it, and I expect you to do it all, especially because this is your first worksheet. This is the first time that we're actually looking at this. So take your time and actually do the work, just so that you get in the habit of doing it, and then you'll know what to do without doing the work. My last point is when x is 2, what is y? Y is equal to 2 times 2 plus 1. Y is equal to 5. So, voila. Table has been officially filled. Great. Question. Now what? Who cares? Why did I just do this, right? What is the point of this? When you graph a line, you need to know the points that are on the line. There are not just random points on the line. These are all points on the line of 2x plus 1. These are all of the points. Well, not all of them, but most of them. You can't just plot random points and say this is 2x plus 1. No, you have to actually test it out. Now, I gave you the x's. Did it really matter whether I picked these x's? No. You could pick any x. I could have picked like x is 10, x is 15, x is 20. As long as I pick several points to graph a line. And like very importantly, and I'll write it out here for you, but you need at least 2 points to make a line. But the more points you have, the more accurate your line is going to be. So I encourage you to start by plotting all of these points, all of these 5 points that I've given you. Put them on the graph. This helps you too because you need to remember x, y, x this way, y this way, x is this way, y is this way. It's good practice for you, okay? So let's start with the first point. At the first point we have x is negative 3, 1, 2, 3, here's negative 3, and y is negative 5, so 1, 2, 3, 4, 5. So our first point from our table that we found is going to go here, okay? Next, we have that when x is negative 2, so negative 2, y is negative 3. So over here, we're going to have our second point. And then our third point, when x is 0, y is 1. So we're going to go here. That is our, what is that called? What do you think that's called here? We'll wait a second and we'll answer in a second, but keep that in mind. What is this called? The next point over here, we have when x is 1, y is 3. So 1, 1, 2, 3. So we're going to have a nice point here. And finally, when x is 2, y is 5. So we're going to have a point up here. Now, my program doesn't have a ruler, so I'm going to draw it out as best as I can. Your line should look something like this. There we go. Looks a little bit more accurate, but your line should look something like this. Now, does your line stop here? No, because you have an infinite amount of points. Like, it basically goes on forever. Okay, so it doesn't stop. It is a linear function that goes on from negative infinity to positive infinity, which you should know what that means by now. Now, let's get back to this point here. What is this point? This point here is called the initial value. So now let's talk about this. In our rule, our slope A is 2, a positive 2, and our B is plus 1. Now, does that make sense? Well, yeah, it does, because if we see here, A is a positive 2, and look, we have a positive steep slope. And when B is positive 1, remember what B is, B is the y-intercept. We can call it the y-intercept. Well, if B is positive 1, does my graph go at positive 1 here on the y-axis? It sure does. So therefore, our function is plotted very, very correctly. This deserves a this deserves a big check mark. So yes, done. Okay. Now that's the first question on the worksheet that you're given. Now I want to look at something that's just a little bit similar. Here is the same thing that you have, except what's that? What does that mean? fx. What does that mean? Now on the worksheet that you're given right now, it doesn't have anything like this. But in the future you will, so I would like to talk about it. What is that? What is fx? Okay, and we'll talk about this more in another class, but I just wanted to give you a little bit of a precursor, and I want to do this question because it's good practice, okay? This actually stands for function of x. Well, doesn't that make sense to you? Because this is technically here, this is technically a function of x. Like, it's literally a function of x. So the reason why we do this, and we're going to look at this in more depth pretty soon, But the reason why it's written like this is because instead of writing y, it's the same thing. F of x is the same thing as y. Sorry, function of f of x, whatever. F of x is the same thing as y. It's the same thing. Okay, except when we write f of x, it just means that it's a function of x, which means that x is your variable. X is what you're looking for, variable. Because sometimes you have equations that don't deal with x, right? Sometimes you have equations that deal with g, h, k, whatever. In this case, my function deals with x. So it's just a fancy way of writing it. Okay? So if we're clear with that, instead, if you're comfortable, or if you're not, instead what you could do is you could just say to yourself that this just means y. It's the same thing, okay? But we call it function of x, and we're going to get into more detail as to why this is important, okay? But for now, if you ever see f of x, just tell yourself that it just means y. Okay, so moving along here, I'm just going to erase this now that we know. What I'm going to keep, though, on this page is I'm going to keep that we know that here, f of x, I'm going to put a star. I'm going to put a star here, and I'm going to say, okay, f of x is equal to y. Okay, keep that in mind. Okay, so now, same thing as the slide here, same exact thing. You're given a function. Over here, it's beautiful, negative x plus 3. You're given a table of values that is completely empty, and I've given you completely random x points. It really doesn't matter. And I've given you a Cartesian plane that I have already incremented it for you. You didn't have to worry, oh, do I go up by 2s, do I go up by 1s? I'm telling you what you should go up by. So, you're welcome. Your job, step number 1, complete the graph. Or no, sorry, complete the table. Complete the table. Okay, so now we have y, or f of x, is equal to negative x plus 3. Now the first number up for grabs here is when x is negative 5. So negative 5, super important. Minus 5 is plus 5. So plus 5 plus 3 is 8. So boom, we have 8. Next we have y is equal to negative x plus 3. Next up for grab, we have when x is negative 3. So y is equal to negative 3 plus 3. Y is equal to 3 plus 3, which is 6. And then we have y is equal to negative x plus 3. Our next number up for grabs is negative 1. So negative 1 plus 3. Y is equal to minus 1 is just plus 1. So we're left with 4. See, like the more you do, just the faster it gets here. Negative x plus 3, y is equal to negative 1 plus 3, y is equal to 2. And last but not least, y is equal to negative x plus 3, y is equal to negative 3 plus 3. So again, all I'm doing is I'm taking each one of these x's, each and every single one of these x's here, and I'm just plugging it into my rule one by one and figuring out what y is. Okay, don't get confused. I know I'm going rather fast. Y is equal to negative 3 plus 3. Well, negative 3 plus 3 is just 0. Okay, so I taken all of my x values that I gave you, plugged it into this rule, and I got all of these as y. Step 2, plot your points. So let's start with this one here. Let me change colors. Purple again. So starting with the first one here, when x is negative 5, y is 8. So here's x at negative 5 and y is 8. So up here we have a point. Next, when x is negative 3, y is, let me just redo that, sorry about that. My program is rather sensitive. 6, 4, 2, 0. We've already plotted this point. Okay. When when x is negative 3, y is 6. So negative 3, 6. Over here we have a point right here. Then when x is negative 1, y is 4. So negative 1, 4. Here we go. -1, 4. Okay, when x is 1, y is 2. So we're here. Oh boy, it did it again. Sorry about that. 8, 6, 4, 2, 0, 8, 6, 4, 4, and then when, okay, so when x is 1, y is 2, remember y, and finally when x is 3, y is 0, so we're on the x-axis here. Now again, you should have a ruler. I don't have a ruler on this, and as you can see, it's very sensitive, so I'm not even going to try to make a straight line. Here we go. Okay, very messy, but you understand. It goes off the graph because it goes on forever. I've only given you some points. Now let's talk about it like we did the last one. What are you given here? You're given negative x, okay, plus 3. Right? That's what you're given. In terms of the slope, our slope, our a, let's do it in green, our a is equal to -1. So it's a negative slope, and it's steep enough, but not totally steep, and so sure enough, we have a negative slope, okay, because our slope is going this way, so it's good. We have a negative slope. Now, what is our initial value? Our initial value, our b, is positive 3. Now, does it look like our graph here is going through -3 at 0? Well, yeah, it does, because it's between 4 and 2. So our initial value, I'm going to write it here, although we don't know for certain, we can see on the graph here that it really looks like it's passing through 3. So I think that everything here looks pretty good. So just to recap, when you're given something like this worksheet, 1, complete the table. The table. Meaning find what y is given x. 2, plot your points. Remember, x side, so x goes from side to side, y is equal to up, down. Okay, and x is always first, y is always second. Okay, and then 3, draw line through the points. And then, for your sake, analyze. Analyze. Is your slope right? Correct slope? Is it negative when it's supposed to be negative? Correct b, or initial value? Does it look like it's going through the point it should be on the y-axis / y-intercept? Okay, there you go. 4 steps to graphing the line based on this worksheet. Okay, and don't forget, if ever you see something that looks like this, it's the same thing as y. This just means f of x, or function of x. And that is all for now. Good luck.